In the last 2 weeks we are going to be going over last year's past paper for the annual exams and explaining every bit in detail. I will be attaching a copy of this past paper, even though the school had already sent the past papers a few weeks ago. Now keep in mind that this past paper is covering topics that were covered last year, and obviously will not take into account that we have reorganized a couple of topics because of the situation we have with COVID-19. As such, the only topic we will be skipping that is included in this past paper will be that of moments. And I assure you we will be going over that next year. First of all, the usual thing, the title, the name, and the teacher's name. So the instructions. Answer all the questions in the space provided. You are requested to always show your working and write the units where necessary. Keep in mind the million, if not billion times I've told you in class to always show the working, always show the formula you're using, and always write the units. And take the value of g, the acceleration due to gravity, to be 10 meters per second squared. I had told you that g at your level should be taken as 10 unless a question specifically tells you to take it as another value. Now if we go down a bit, these are the equations that you are given. Now I'm sure you are remembering a couple of these. So we talk about density, pressure, we've done those, work, alright? But the rest we haven't covered. So we haven't covered all of waves, we've just done one of the equations, we haven't covered electricity. But for any physics exam that you will be having from now until your end of physics at the end of year 11, you will always have all of the equations. So it is up to you to study the equations, remember what the symbols mean, and use them properly. Now for those who think that since you have the equations you don't have to study them, that is an extremely incorrect way of thinking. Because if you don't remember what each symbol means and how it is to be used, then you're definitely not going to use them well and you're not going to get the marks required. And at the bottom there is simply the marks that you should be used to by now. Okay, let's start from question 1 on page 2. Question 1. The diagrams show the arrangement of the particles in a solid and in a gas. Each circle represents one particle. Complete the diagram below to show the arrangement of particles in a liquid. Okay, so solids are finished, they are tightly packed and in order. Gas is also finished, you only have 3 loose particles. And we have to finish off the arrangement for liquid. Now remember, in a liquid, the particles still have to be touching, but they cannot be in order. Something like this. Particles are touching, and most of them are not in perfect order. Question 1b. Explain in terms of particles why gases are easy to compress, but liquids and solids are not. So the reason we had said in class that gases are compressible, whereas liquids and solids are not, is that gases have a lot of space between them. So if you apply a force, you can easily push the particles closer together. Whereas with solids, you definitely cannot, because there is no space. And with liquids, it is also extremely difficult because there is very little space between the particles. So gases have a lot of space between their particles. So when compressed, the particles can easily be pushed into these spaces, whereas solids and liquids have very little to no space as the particles are touching. Question 1c. Explain in terms of the particles what happens to an object undergoing thermal expansion. So as an object is heated, its particles gain energy, which will cause them to move more, taking up more space, causing the volume of the object to increase. We had gone over a number of examples of expansion. If you remember, we talked about the Eiffel Tower and how much it expands during summer. We talked about train tracks buckling. We talked about expansion joints in bridges. And all of that happens because as the object is heated, the particles, in the case of solids, vibrate further about their fixed position. Okay, they vibrate more. And so they end up taking more space. So the overall volume of the object will increase. Question 1b. State two conditions needed to increase the rate of evaporation. Now, even though the question asked us for two conditions, I'm going to write all four of them. So to increase the rate of evaporation, not just to affect it, but to increase it, you can increase the heat or the temperature, increase the surface area, like we had mentioned with salt pans, having air currents present, and decreasing the humidity. Now, in the case of this question, any two of these would have been correct, and you would have gotten all of the marks. Question 1e. Explain how the evaporation of a liquid causes the temperature of the remaining liquid to decrease. We had mentioned this a number of times, including our mid-yearly exam and our homeworks, where we said evaporation is a cooling process. Why is it a cooling process? Because as one particle evaporates, it takes with it energy that it would have stolen from the other particles, which means the other particles are left with less energy. And if the average energy of the liquid that is left, that has not evaporated, is less, then that means that the temperature is less, because the temperature is directly related to the average energy of the particles. So since evaporation happens below the boiling point, then for a particle to evaporate from the surface, it has to steal energy from the other particles in the liquid. So as one particle evaporates, it would leave the remaining particles with a lower average energy, and since temperature is linked to the average energy of the particles, then this will be less as well. That concludes question 1.